This is example problem 2 from topic 10, biochemical redox reactions. So for this problem, determine the oxidation state for each carbon atom in the following compounds. So let's look at the top compound and look at the first carbon atom I recognize at being the carbonyl carbon, and determine the oxidation state for this carbon. So we must look at the substituents that are attached to it, and based on the priority rankings of oxidation state, 8 being the most potential to be oxidized and 0 being completely oxidized, the value of this carbon is going to be ranging from 0 to 8. So we can determine it by looking at the substituents. The substituents here, we have an oxygen, and another carbon over here. So when we prioritize these, we look at the bond, and the 2 electrons that are in this covalent bond are assigned to the carbon or the substituent or to both. In this case, oxygen gets the electrons because of electronegativity, and so based on the assignment here, 0. This carbon, neocarbon, and oxygen connection, 0. Carbon-carbon bond, 1 to this carbon, to carbonyl carbon. So the oxidation state here is 1. Let's look at the next carbon. Starting at the top, we have a carbon. That's going to be 1 to the carbon it's circled. We have the carbonyl carbon. It's over here. And so that's going to be 1 for each. So it makes this 2. The oxygen here, 0. Then the hydrogen. All those electrons go to the carbon. So the carbon now has an oxidation state determination 4. Let's go through the next compound. There's the carbonyl carbon. Let's start off with the hydrogen to the right of that. So that's going to be 2 carbons. Excuse me, 2 electrons to the carbonyl carbon. And the carbonyl oxygen, 0. And then the bond to the carbon that's over here. And you're going to have a value of 3, the oxidation state. Let's look at this carbon. Give you a chance to do that on your own. Okay, the thing I want you to recognize is that there are 2 hydrogens coming off of here that weren't drawn in. So that's going to be 2 4 electrons, and then 1 saved with this carbonyl carbon over here. So that's going to give you a total of 5 for the oxidation state for that carbon. You look at the compound at the bottom. Look at the carbonyl carbon. Determine the oxidation state for that. Oxygen 0, oxygen 0, carbon connection 1. There's a carbon here. Carbon 1, oxygen 0, hydrogen 2, carbon 1. It's 4. And we have this methyl carbon, 3 hydrogens. So that'd be a total of 6, plus 1 from carbon is 7. So that's how you do the oxidation state determination. It isn't difficult as long as you remember the rules. However, it does provide you some insight into the molecules. So I'd like to spend a few moments talking about that. So if we look at these molecules, they all have a carbonyl carbon that are present. Notice the oxidation state of this carbonyl carbon is different in one of them. It's 1 here, it's 3 here, it's 1 here. The higher the number, the higher the potential for oxidation. There's more electrons to give up and to have it become oxidized. So this carbonyl carbon has the propensity to oxidize compared to the other two. If we look at the functional group between the first two, we know the aldehyde is more reduced than a carboxylic acid. Therefore, the aldehyde has a potential to be oxidized to give up electrons. This is important in recognizing what is being oxidized and what is being reduced in redox reactions. So oxidation assignment of carbon atoms can be helpful in this regard. I'm introducing it at this point in the class, but it will be used quite a bit when we go through metabolic pathways later in the course. So make sure you understand how to determine oxidation states of carbon atoms in metabolic compounds, such as those shown here. There are more problems for you to try in the posted problem sets.